Hi friends, welcome to the Smart Crack series for NEET 2022. And in this series, what we do is we pick very important topics from each chapter of your NCERT physics book, and we understand those topics as far as NEET exam is concerned, and we solve some problems based upon those topics. Okay, so the problems which were asked in the previous year NEET exams. So let's begin. Our today's topic is Newton's laws of motion. Okay, the laws of motion chapter. So we'll break this chapter into two parts. First part we'll cover today, and the second part, which is based upon the free body diagrams, that we'll cover on tomorrow. Okay, so we'll see some free body diagrams today also, but more on that, much more we'll see on tomorrow. Okay, so let's begin. So we know, everybody knows Newton's laws of motion, right? So Newton has given three laws of motion. Okay. So what are those three laws? The first law is every object continues its state of rest or of uniform motion along a straight line unless it is acted upon by an external unbalanced force. So this law is known as what? Law of inertia. Right. So what does it say? So if you observe some body at rest, so let's suppose you observe some car, okay, it is at rest, okay, or there is some another car which is moving with uniform velocity, okay, v is constant along a straight line, then Newton's first law says that there is no net force acting on these two bodies. So he says that the state of rest and state of uniform motion are identical. Okay, so what are the forces acting in these two cases? So in first case, there is a force acting downwards, that is weight of this car, and there is a normal reaction due to the road surface. Okay, normal reaction due to road surface, it acts upwards. So these two forces are balanced out, and therefore the net force acting on the car is zero. In second case also, there are two forces only. First force is the weight of the car, and the second force is the normal reaction. Okay, so in both these cases there are only two forces and they are cancelling out each other, so state of rest and state of uniform motion is same. Okay, that is Newton's first law of motion. Every body continues to be in its state of rest or of uniform motion along a straight line unless there is some external unbalanced force acting on that body. Okay, so it doesn't matter if there are forces acting. What matters is if those forces are unbalanced. Okay, so next, this tendency of body to continue its state of rest or of uniform motion, it is known as its inertia. Okay, so what is inertia? It is the resistance of an object to change its state of motion. So objects, if they are at rest, they like to be at rest. If they are moving with constant velocity in a straight line, they want to continue to do so. Okay, so let's consider this example. So let's suppose there is this bike which fails on the road, and you can consider you are riding in a car and it also fails on similar. So we know that it will be much more difficult to push a car to the garage in comparison with the bike. Okay, so what is difference between car and bike? So difference is in their masses. So mass of this car, mass of car is much more compared to mass of bike. Okay, and this mass gives the tendency of body to resist the change in motion. So if mass is more, then tendency of body to resist the change in motion is more, and we say that its inertia is more. Okay, after that, so this is about the Newton's first law. Okay, so all these Newton's laws, they are applicable in a particular frame of reference. Now what is frame of reference? So frame of reference means you have some coordinates, okay, x, y, z coordinates, okay, and a clock. All right, so there are two kinds of frames of reference. So what is frame of reference? Basically, there is an observer who is watching the motion, okay, a coordinate system, and you have a clock to mark the motion, okay, to mark the position of any object at some given time. So from that position, what you can find out? Its velocity, its acceleration, etc., etc. Okay. So there are two frames of reference. First is inertial frame of reference, and second one is non-inertial frame of reference. So Newton's laws are strictly valid in the inertial frame of reference only. And what is the inertial frame of reference? So there is no external acceleration. Okay. So for an example, this failed bike, okay, it is the inertial frame of reference. Or let's suppose you are in a moving car. Okay. Let's suppose you are in a car which is at rest. That means there is no external unbalanced force acting on you and you are observing motion of other bodies, then you are in inertial frame of reference. And if the car is moving with constant velocity, still the forces are balanced. That means there is no acceleration. It is also an inertial frame of reference. What is non-inertial frame of reference? If your car accelerates, that means there is some net force acting on the car. Okay. So inertial frame of reference, there is no acceleration acting on the observer. Non-inertial frame of reference, observer is accelerating. Okay, so in inertial frame of reference, Newton's laws are true. In non-inertial frame of reference, they are not true. Okay, so this is the difference between inertial and non-inertial frame of reference. After that, okay, so is Earth an inertial frame of reference? So our Earth, is it an inertial frame of reference? So now I had taken this class when I was teaching to the 11th standard. So these are those notes only. So now we can consider Earth. Okay, it revolves around Sun. So there is one centripetal acceleration acting on Earth, which is along the radius and towards center. That means towards Sun. Okay, it is due to the gravitational force. And then there is Earth, Earth's rotation. So Earth also rotates about an axis which passes through its north-south poles. So there is another acceleration due to the rotation of Earth. Okay, so every object on Earth will move in circular motion. Okay, so that means every object on Earth feels some acceleration due to Earth's revolution around Sun and due to Earth's rotation. So Earth is not strictly an inertial frame of reference, but if we calculate these accelerations, they are very, very small. Okay, so it turns out to be 0.034 meters per second square. This is the acceleration due to Earth's rotation. Okay, it's very, very small, and acceleration due to Earth's revolution is even smaller. All right, and that's why we can consider that the acceleration due to Earth's revolution and rotation, it's so negligible compared to our day-to-day observation that we can neglect that. All right, so Earth is inertial frame of, fairly inertial frame of reference, we can say. Okay, approximately. Then this was about Newton's first law. Now let's talk about Newton's second law. Okay, so let's consider this example. So suppose you are on a cycle. Okay, you are riding a cycle. All right, so then you are riding a cycle, and this second example, you are riding in a car. Okay, so now there is one quantity that we need to find out. It's momentum. So what is momentum? It is product of mass times velocity. Okay, so now your mass would be something. Okay, and you will have some velocity. So product of mass and velocity is momentum. So clearly, if mass is more, momentum will be more, or velocity is more, then momentum will be more. Okay, so now Newton's second law says that the force depends on the change in momentum. Okay, so for an example, so there is a car, okay, moving on a road with some velocity. All right, so there will be some mass of car, and let's suppose its velocity is 1 meter per second. After that, let's consider a truck, okay, which is moving on same road with same velocity, but its mass is much more. And let's suppose that car, it collides with a person. Okay, there is an accident. So the person will have some injuries. Okay, he will be pushed away. All right. So in comparison with this car, if you take a truck, what will happen? So in this case, the casualty can be much more. Okay, and if you think about the force will be much more, force due to the truck. So in this case, which thing is more? So its mass is more. If velocity is same for these two bodies, then which body applies more force? Whose mass is more. All right. So same thing. Now let's suppose a car comes towards you and you want to stop it. Okay. A truck comes towards you and you want to stop it. So both of them are coming with same velocity. So you will have to apply more force to stop a truck in comparison with a car. Okay. So that means force depends on what? It depends on mass. Now you can consider another scenario. So if car comes with 1 meters per second, then the force you have to apply to stop it. Or another scenario in which the car comes with the velocity of 5 meters per second. So of course, if it comes faster, then you will have to exert more force to stop it. So that's what Newton's second law says. It says that the rate of change of momentum of a body, okay, so it says that the momentum is an important quantity and it's not just the velocity. Okay, it is product of mass and velocity. Mass is important, velocity is also important. That means the mass and velocity, the product of mass and velocity, it has something to do with the state of motion. Okay, so which term signifies state of motion? It's the momentum. All right. So Newton's second law says that the rate of change of momentum of a body, it is directly proportional to the applied force and it takes place in direction of the applied force. Okay. So yeah. Okay, I will just erase this and I will write Newton's second law over here. So Newton's second law says that the force brings out change in momentum in a body. Okay. So force is directly proportional to rate of change of momentum. And since there was no concept of the force, okay, before, or there was no measure to quantify a force before Newton's laws, okay, so there will be some unit of force, right? So now I can write force is directly proportional to what? Rate of change of momentum. So it will be some constant times change in momentum with respect to time. Okay. So now this constant k can be anything. Okay. And because Newton's laws were being discovered at the time, so physicists, they kept the thing simple and they kept this constant k equals to 1. Okay. So then the unit of force that comes, it is called as Newton. Okay. So unit of force is Newton. So now you can take derivative of this momentum with respect to time. It is d by dt of mass times velocity, because momentum is mass times velocity. So if you take its derivative, then you have dm by dt. Okay. So derivative of first term multiplied by second term as it is, plus derivative of first term as it is multiplied by derivative of second term dv by dt. Okay. So now if there is a case when mass is constant, okay, if m is constant, so I'm sorry, Okay, so if m is constant, if and only if, then we can say that force is equal to m into dv by dt, right? So we can't say that force is equal to mass into dv by dt if m is not constant. So if m is constant, in that case we can say F is equal to m into dv by dt. I am covering this because there were questions based upon this. And so dv by dt, we know it is acceleration. So force is equal to mass into acceleration. This is our famous Newton's second law in the famous form. Okay. So this is the Newton's second law. Then let's consider a quantity called impulse. Okay. So Newton's second law says what? If we consider that initial momentum of a body is m1v1, this is p1, final momentum of body is m2v2, then force acting on this body will be equal to what? It will be final momentum minus initial momentum divided by final time minus initial time. Okay, so it is m2v2 minus m1v1 divided by t2 minus t1. So if you take this t2 minus t1 on the other side, what do you get? You get force multiplied by t2 minus t1, change in time, and this quantity is called as impulse. Okay, this is called as what? It is known as impulse, and it's equal to what? So if you see here, okay, it is m2v2 minus m1v1. So impulse is equal to what? It is equal to change in momentum. Okay, so impulse gives us change in momentum, right? So now what is the use of this thing? So there are some cases where we cannot find out force. Okay, we can just measure the effect of force. And what is effect of force? It is change in momentum. So we say that there is this much of impulse due to that force. Okay, what are those cases? So the cases where the force is very fast and it brings out very big change. Okay, for an example, this example of a ball hit by a bat. Okay, the impact time, it's very small. All right, so finding out force is very difficult because measuring that time is very difficult. Nowadays we can measure it. Okay, there are fast cameras, but earlier it used to be very difficult. So people came with the concept of impulse. Okay, it is force multiplied by time of impact, and that's equal to what? Change in momentum. Okay, then another example you can consider that somebody jumps from a very tall building and falls down. Okay, so then what will be impulse? Impulse is change in momentum. Okay, impulse is the impact of force due to earth on that body. Okay, all right. So then this was impulse that we considered. It was due to a constant force. Okay, and impulse is denoted by letter J. So if we consider these two examples, in first example the force is constant. Okay, here force is constant, and in the second case force is variable. So what is impulse? So if we consider this much time interval from t1 to t2, then force is constant, the value of force does not change. Okay, and we want to measure its impulse from time t1 to time t2. So what will be the impulse? It is force multiplied by that time. So if you see it in this curve, what is it? It is the area under this curve. All right. What is impulse? Impulse is the area under force versus time curve. So in this first case, finding out impulse is easy. It is just force multiplied by I'm sorry. It is just the force multiplied by time interval. In the second case, force is variable. Okay, so the graph of force and time, force we plot on vertical axis, time on the horizontal axis. So graph is not a straight line, it's something like this. Okay, so now how do we find area under such a curve? So we have seen this in last chapter and also in last chapter. So to find area under such a curve, what we use is derivative. Okay, so we break this area in n number of small intervals. If you consider this interval, so this is force at some time t, this is F at some time t, and this is approximately a rectangle. So what will be area of this rectangle? So it is f of t multiplied by this width, which we say is delta t. Okay, so f of t times delta t. It is the impulse in that much small duration. Okay, so delta j. So after that, now if you take such small areas and you add them all, you add all those areas, what do you get? You will get total impulse. Okay, the total area under the curve. So this process is known as what? Integration. Okay, so we integrate f of t delta t or f of t dt from t1 to t2, from this time to this time. Okay, so here from this time to this time. So what is impulse? We need to know that it is area under force time curve. All right. So is it clear? Yes. Clear? Shall we move on? Okay, let's move on to the Newton's third law of motion. So what is Newton's third law? It is famous. We know to every action there is always an equal and opposite reaction. This is the Newton's third law of motion. All right. So let's suppose we have, for an example, let's suppose we have this two spring balances. Okay. So if they are connected to each other and one balance is connected to this rigid support, and we take another balance in our hand and we pull it, we'll see that the readings on these two balances is equal. So first balance pulls on the second balance pulls on the first balance, and the force with which they pull on each other, it is equal. All right. So this proves the Newton's third law of motion. Okay, to every action there is always equal and opposite reaction. If we take another example, let's suppose we fire a bullet from a gun, we get a recoil. So gun exerts force on the bullet in forward direction, and the bullet exerts equal and opposite force on the gun in the opposite direction. Okay, so this is Newton's third law. There are some points to be remembered regarding the Newton's third law of motion. These forces always occur in pairs. That means if you exert force on one body, then there is surety that that body will also exert force on the first body. Okay, it will never happen that you will exert force on one body and that body won't exert force on you. Okay, then action reaction forces act on again sorry okay action reaction forces act on different bodies and not on same body. Okay, so for an example, let's suppose this boy, okay, he is standing on this floor, then his weight acts on the floor and floor exerts a normal reaction. Okay, this is called as reaction because it is reaction. Okay, it is answer to this force. Okay, but both happen at the same time. Reaction doesn't mean that it happens afterwards. Okay, so action and reaction happen simultaneously. There is no cause and effect relation between them. And after that, the action and reaction forces always act on different bodies. I think I have written it twice. Okay, so these are some points to be remembered regarding the Newton's third law of motion. Okay, after that there is one more law which is called the law of conservation of momentum. So let's see what is that. So law of conservation of momentum says that, let's suppose there is collision between two bodies, then the total momentum before collision is equal to total momentum after the collision. And what is reason for that? The reason for that is, if you consider system of these two bodies, okay, so here if you consider these two balls, then the total force acting on that system is zero. Why it is zero? Because there is equal and opposite force, okay, exerted by both the bodies on each other. So net force is equal to what? Zero. Okay, so net force is equal to zero if you consider both the bodies, and therefore what will happen? Since net force is zero, the change in momentum will be equal to zero. So total momentum before collision is equal to total momentum after the collision. Okay, so if you call them A and B, then M1 UA1, okay, sorry, you are calling them A and B. So mass of A is ma, initial velocity of A is ua, plus mass of B is mb, initial velocity of B is ub. So ma ua plus mb ub is equal to ma va plus mb vb. All right, so this is the law of conservation of momentum. Okay, after that let's move on to the next topic, and the next topic is the common forces in mechanics. So what are the common forces that we observe in the mechanics? So the common forces are the normal reaction that we have seen just now, then the spring force, tension in the string, okay, then drag force, etc., etc. Okay, these are contact forces, and there are some non-contact forces: gravitational force, okay, electrostatic force, magnetic force, etc. So let's look at them one by one. So what is gravitational force? So if you have any two masses, two bodies having masses, then each of them exert forces on each other, okay, and that force is directly proportional to product of those masses and inversely proportional to square of distance between them. This is the universal law of gravity. Okay, so force is proportional to m1 m2, it is inversely proportional to r square. So if you remove proportionality sign and put an equality sign, you will get F is equal to G times, G is the universal gravitational constant, that G times m1 m2 upon r square. Okay, so this is the gravitational force. Okay, then next force is the electrostatic force. So what is electrostatic force? So if you take two charged particles, then both of them exert forces onto each other. Okay, so there is attraction between unlike charges, positive and negative, and there is repulsion between the like charges. Okay, so like charges repel each other, unlike charges attract each other. So the force between them is called as the electrostatic force, and that force is also directly proportional to product of those two charges, q1 and q2, and it is inversely proportional to r square. Okay, so F is equal to, if you remove the proportionality sign and put an equality sign, a constant will come. So F is equal to K times Q1 Q2 over R square. Okay, that is the electrostatic force. Then next is spring force. So what is spring force? So if you stretch a spring by some distance, what happens? It tries to restore itself back. Okay, so the restoring force generated in the spring, it obeys some law. It is known as Hooke's law. What is that law? So this force, the spring force Fs, it is directly proportional to displacement, and it acts in the opposite direction of displacement. Okay, Yeah. Hi, Anusuya. Good morning. So it acts in the opposite direction of the displacement. So force is directly proportional to displacement and it acts in opposite direction of displacement. So this is known as the Hooke's law. And if you remove the proportionality sign and equality sign, if you put, then a constant will come. If you call it K, so this K is known as the spring constant. Okay, this K is known as what? It is known as spring constant. Alright, so this is force generated in a spring. It always acts in opposite direction to that of the displacement. Next force is tension in the string. Okay, so let's suppose you have a string like this and you connect a mass like this. Okay, so you hold that string or a rope in your hand and the mass is hanging, okay, from some end, from one end of that rope. So the weight of that mass will act downwards and the rope is, you are holding the rope. Okay, so now if there were no other force, then what would have happened? The mass would have fell down. Okay, so the mass doesn't fall down, it's because of there is another force. Which is that another force? It is the tension in the string. Okay, so that tension in the string balances the weight of the stone or that mass and therefore the mass doesn't fall down. So what is the cause of this tension in the string? So what happens is, let's suppose you have a rope or a string, then yeah, hi Sanjana. So you have a rope or a string, then different atoms or molecules within that string, they are held with each other by means of some force. We call it interatomic if there are atoms, we call it intermolecular if there are molecules. Now, what happens if you stretch on a string, the distance between atoms or molecules changes. Okay, and this interatomic or intermolecular force, it is just like our spring force. So if you increase the distance, what will happen? It will try to restore it back. If you decrease the distance, again it will try to restore the distance back. Okay, so atoms or molecules, they want constant distance between them, and that's why some forces, restoring force is generated, which we call over the scale of string the tension in the string. Okay, so that's the origin of the tension. All right, and next we'll talk about one more force, and it is known as the frictional force. So what is frictional force? So now let's consider this example. So let's suppose this is some block of some mass and this is me. So I want to push it. Okay, I want to move it from one point to some other point. Okay, so I exert some force on it, then what will happen? So if I exert very little force, there is possibility that it will not move. So why it wouldn't move? It's because there is some force which is opposing me, and that force opposes the relative motion of this block with respect to this surface. So that force is known as frictional force, static frictional force. Okay, then suppose I increase my force, what will happen? At some point that block will begin to move. Okay, so this frictional force has some maximum value. If you exert force lesser than that, the frictional force will exert, the frictional force will be equal and opposite. But if you keep on extending your force, increasing your force, then the frictional force has some maximum limit. It can't cross that limit. It cannot increase beyond that limit. Okay, so it is known as the limiting value of the static frictional force. Now this frictional force, as we discussed, it is self-adjusting force and there is some maximum limit to this static frictional force. Okay, and there is law of static friction that if you measure this frictional force, you will find out that it is directly proportional to the normal reaction. How much is normal reaction? So this block is resting on the ground, its weight is acting downwards, the normal reaction due to the surface acts upwards, It's equal to what? It should be equal to mg, otherwise there will be acceleration in vertical direction. So there is no acceleration in vertical direction. That means the normal reaction is equal to mg. Okay, it's just equal to the weight in this case. Okay, so the maximum value of static frictional force is directly proportional to what? Normal reaction. Okay, and if you remove the proportionality sign and put an equality sign, a constant will come. So fs max is equal to, is it visible? I will just write here, fs max is equal to that constant which we call coefficient of static friction multiplied by the normal reaction. Okay, so that coefficient of static friction we measure using some process. So I will tell you how do we measure it. Before that, let's talk about kinetic friction. So now, once you move that block, what happens? Now, if you stop exerting some force, the block will stop moving after covering some distance. It happens because there is still some friction, okay, but it is lesser compared to the initial case. So the initial case is when block is at rest, you need more force to set that block in motion. Once you set the block in motion, then you need to keep on exerting lesser force, okay, compared to the previous case to keep that in motion. Okay, so why the force, the lesser force is required now? Because now the friction has reduced. Once block begins to move, the friction between the surface and the block surface is reduced. Okay, so this friction is known as what? The kinetic friction. So coefficient of kinetic friction is less compared to the coefficient of static friction. What? Why kinetic? Because now it's moving already. Okay, so it is still proportional to the normal reaction. So kinetic friction can be written like this: Fk is equal to what? Mu k times the normal reaction. Okay, where mu k is the coefficient of kinetic friction, but it is less than that of the static friction. All right. So then next thing that we want to discuss is the angle of friction. Okay, so for that, what I will do is I will consider this example of a block like this, and it is resting on this plane. Okay, and this is a plane which is rotatable. So initially, suppose it's like this. This is the block resting on the plane, and then you move it like this. You rotate it. So at some point, what will happen? The block will begin to slide. Okay, it begins to slide. So at that point, the frictional force is less than the external force, right? So there is some angle for which what will happen? You will reach the maximum value of frictional force. Okay, so if you do the calculations, you will find out that mu s is equal to tan of that angle, the angle at which this block will begin to move. Okay, all right. So yeah, we need not go into the origin of friction. So that's about it for the theory. Now let's discuss some problems. So if you have any question, you can ask me. Do you have any question? Okay, so let's discuss some problems. So first problem is the force F acting on particle of mass m is indicated by force time graph like this. So force on vertical axis, time on the horizontal axis, the change in momentum of the particle over the time interval from 0 to 8 s is from 0 to 8 seconds. What is the change in momentum? That we have to find out. So force versus time graph, as we discussed, it gives us what? It gives us the impulse, that is change in momentum. So if we find area under this graph. But that area is signed area. What do I mean by signed area? So when you take an integral, the area above the x-axis is positive. Okay, if you are towards the right hand side of the y-axis. Okay, and that's generally the case in physics. So area above the x-axis is positive and area below the x-axis is negative. So this area would be positive and the area that I will show with the red will be negative. Okay, so we can easily find out area, right? So what is the area of a triangle? Area of a triangle is half of base into height. So let's call this point A, this point B, okay, this point C and this point D. So area from O to B, it is area of a triangle equals to half of base into height. So base is how much? From 0 to 2. Height is how much? It is from 0 to 6. Okay, so 6. So 2 and 2 gets cancelled. So we have 6. And what will be unit of this? So unit will be kilogram meters per second because this is impulse. Okay. Then area from B to C, from here to here. So we are going from 2 to 4. Okay. So 2 to 4, how much is the time duration? It's 4 minus 2, that's 2. Okay, so area from B to C is minus of, as we have discussed, area above the x-axis is positive, area below the x-axis will be negative. So it is minus of this distance from B to C multiplied by this height. Okay, so height is 3, right? So it is 2 multiplied by 3, so it's minus 6. And what about this area from C to D? So area from C to D is equal to how much? It's from 4 to 8. So T is how much? It is 4. And how much is the height? It is 3. Okay, it's up to here. So it's 3. So it is base into height, that's 12. Okay, so what is addition of all this? So 6 plus minus 6 is 0. 0 plus 12 is 12. So what is the answer? It is 12 Newton second. Okay, kilogram meter per second is also Newton seconds. Alright, because it is impulse. Impulse is product of what? Impulse is force times time. So unit of force is Newton, unit of time is second. So unit of impulse will be Newton second. Okay. On the other hand, it is change in momentum. This will be equal to what? Change in momentum. And unit of momentum is kilogram meter per second. Okay. So another unit for the impulse is kilogram meter per second. Alright. Yeah. So is it clear? Shall we move on to the next problem? Okay. Let's see next problem. So next problem is a body under the action of force, this is the force, acquires an acceleration of 1 meter per second square. The mass of this body must be, what will be mass of this body? So we are given with the force, we are given with acceleration. So force is this much, 6I minus 8J plus 10K cap, and acceleration equals to 1 meter per second square. So if we consider Newton's second law, force is equal to mass times acceleration. Okay, but before that we are given force in the vector form and acceleration is scalar. That is, we know only the magnitude of acceleration. So we need to find out magnitude of this force. So what will be magnitude of force? It is square root of fx square plus fy square plus fz square, right? So it is 6 square plus minus 8 square plus 10 square, and that's equal to square root of 6 square is 36, 8 square is 64, 36 plus 64 plus how much? 100. So it is 100 plus 64, 164 plus 36 is 200. So square root of 200, right? Or 2 times square root of 100, which is 10. So we get 10 outside, so 10 root 2, and acceleration is 1. And we can say force is mass times acceleration. That means mass is force upon acceleration. So it is 10 root 2 divided by 1. Okay, that's 10 root 2. So option C is the answer. Okay, it's very simple. Is it clear? Okay, so let's move on to the next problem. Next problem is sand is being dropped on a conveyor belt at the rate of m kg per second. The force necessary to keep the belt moving with constant velocity v meters per second will be. Okay, so the sand is being dropped at the rate of what? M kg per second. Okay, so change in mass we can say with respect to time. Okay, the mass that is being deposited on this belt, so sand is being dropped on this belt, so the net mass which is being deposited on the belt with respect to time is how much? It is given to be m. Okay, so now there will be some mass of this conveyor belt. Okay, let's call it m, whatever m, pick c, which is constant. Okay, and the mass that's being deposited is suppose m. The mass of sand collected over here is suppose m, or let's call it ms. Ms is the mass of sand. Okay, now question is, if the velocity is constant, velocity of this thing plus this thing, mass of sand, okay, the sand plus the conveyor belt, total velocity is constant, then what force is necessary to keep it constant? Okay, so we know the Newton's second law, force is equal to what? The change in momentum with respect to time. So d by dt of total mass, okay, is suppose total mass m suffix t is equal to mass of this conveyor belt plus mass of the sand. Okay, so total mass multiplied by velocity of this total thing. Okay, so it is equal to derivative of this thing with respect to time, okay, into velocity plus mass, the total mass multiplied by derivative of velocity with respect to time. But velocity is constant, that means this second term is 0, and we are left with this first term only. And we are given what is the change in mass of sand with respect to time? It's capital M. So if we put that, what do we get? So that means the force is equal to that capital M multiplied by V. Okay, very simple. Clear? Option C is the answer. Yes? Any questions? Okay, so I guess no questions. Let's move on to the next problem. The next problem is an object of mass 3 kg is at rest. Now a force of F equals to this thing is applied on the object, then velocity of object at t equals to 3 seconds is. So we want to find out velocity. We are given with force. So we need to find out what? Acceleration, right? So what would be acceleration? Acceleration is force upon mass. Okay. So it is equal to what's Yeah, it's equal to 6t square into I cap plus 4t times j cap divided by how much is mass? Mass is 3. Okay, all right. So it's equal to, you can write it as 6 divided by 3 is 2, 2t square into I cap plus 4 by 3 t into j cap. This is the acceleration. And what do you want? You want velocity at time t equals to 3 seconds. Okay, so you can write this acceleration as, okay, I will write it as dv by dt. It's equal to this thing. Okay, then what will be dv? So dv can be written as, if we take dt on other side, so this thing means this acceleration multiplied by dt. Okay, and then we can integrate it from the initial time, which is 0, to the final time, which is 3, to get the change in velocity. Okay, so we get integral of dv from 0 to 3 is equal to what? Integration of from 0 to 3 of 2t square I plus 4 by 3 t j, 2 times t square into I cap plus 4 by 3 j, 4 by 3 t into j cap, okay, dt. And we know how to integrate this. So we can take 2 outside, then it will be integration of t square dt. Okay, we can take I cap also outside because it is also constant, plus we have 4 by 3 into I'm sorry, integral from 0 to 3 of t dt. Okay, j cap. So it is equal to, what will be integral of t square dt? So we know the formula for integration of t raised to n. What's that? T raised to n plus 1 divided by n plus 1. So here the value of n is 2. So it will be t raised to 2 plus 1 upon 2 plus 1, that is 3. Right? So it is 2 times I cap into t raised to 3 upon 3, and it is from 0 to 3. The upper limit is 3, lower limit is 0. Then we have 4 by 3j multiplied by, so it's integral of t dt, it means integral of t raised to 1 dt. Okay, it will be equal to what? T raised to 1 plus 1 divided by 1 plus 1. So it is t raised to 2 upon 2 from 0 to 3. And now we can substitute the limits. So since lower limit is 0, we just have to substitute the upper limit. So it is 2 I cap into t cube, that means 3 cube divided by 3. So it will be 3 square. Okay, 9. Right? This 3 cube upon this 3. So 3 square, basically 9. Plus 4 by 3 j cap into t square. So it is 9 upon 2. Okay, and if we do calculations, so this will be what? This is velocity at 3 seconds minus velocity at 0, but we are given that velocity of at 0 is 0. So this is 0. That means we have velocity at 3 seconds. Okay, and how much will be that? So this is 9 multiplied by 2. So 18 I cap plus, this will be 4 by 2. Okay, 4 by 2 is 2 and 9 by 3 is how much? 9 by 3 is 3. 3 times 2 is 6. So plus 6 j cap. Okay, so I guess this should be the answer. 18i plus 6j. Yeah, this is option B. Okay, so is it clear? Yeah, is it clear or there are any questions? No questions? Okay, good. So let's move on to the next problem. So next problem is, a cricketer catches a ball of mass 150 gram in 0.1 second. Okay, there is a cricketer catches a ball of 150 grams in 0.1 second, moving with speed of 20 meters per second. Then he experiences force of. Okay, so when he catches the ball, what will be final velocity of ball? It will be 0, right? So the initial velocity u is something, it is 20 meters per second. Final velocity is 0, right? And what will be force? Force is equal to mass into acceleration, since mass of the ball is not changing. So it is m into acceleration is v minus u upon t. So that is, what is mass? 150 gram. So 150 multiplied by 10 raised to minus 3 in kilograms. Okay. So multiplied by v is 0 minus u is how much? U is 20 meters per second. And what is time? So time is 0.1 second. So let's calculate it. It will be 150 into 10 raised to minus 3. So this will be 0.15 multiplied by, we have 20 upon minus 1. 20 upon 0.1. It will be 200. Okay. And we have this negative sign. But it doesn't matter since we are just asked about the magnitude. Okay. So 200 times this, it will be 0.3 times 100. So I guess it is 30. Okay, so minus 30 newtons, but we only need magnitude, so it is 30 newtons. Okay, yeah, it was simple. Okay, let's move on to another problem. So this is from NEET 2016. A rigid wall of mass m strikes a rigid ball. Earlier it was rigid ball of mass m strikes a rigid wall at 60 degrees. Okay, so this is 60 degrees and gets reflected without loss of speed as shown in the figure. The value of impulse imparted by the wall on the ball will be. So what happens? Initially, see, there is some velocity. Okay, and it gets reflected without loss of speed. So speed remains constant. Okay, so what happens is only the direction of velocity changes. Okay, so now speed is constant initially. This is v, you can say. So initial speed, let's call it v1. Initial velocity, you can resolve it in two components. So if this angle is 60 degrees, this angle will be 60, right? So this angle is 60. So right now let's just call it theta. Okay, so this component v1, it will be v1 cos of theta, and this component will be v1 sine of theta. After reflection, it goes like this. So it can also be resolved in two components. So the final velocity, let's call it v2. Okay, so this is v2. It can be resolved in two components. So this angle is theta, suppose. So this is v2 cos of theta. This is v2 sine theta. So magnitude of v1 is equal to magnitude of v2. Okay, because speed remains constant, so magnitude is v. Okay, so now you can look at the components. So what happens to the vertical component? It was downwards, it is still downwards. That means there is no change in the vertical component of velocity. Okay, what about the horizontal component? So it was towards right earlier, now it is towards left. So there is change in the horizontal component, there is change in the direction. Okay, so what will be change in momentum? There is no change in momentum in y direction because velocity in y direction is constant. but there is change in momentum in x direction because the velocity in x direction is changing its direction. Okay, it is reversing its direction. Okay, so we have what, let's call it, okay, v2x is v2 cos theta. Okay, so if we consider this to be, this will be along negative x-axis, so I'm putting minus I cap. Okay, and v1x is what, v1 cos theta, or I will just write v cos theta because v1 is equal to v2. Okay, so I will just erase this 2. All right, so v1x is equal to what, v into it is also v into cos of theta, but its direction is positive, right? So what is change in speed? So change in speed delta v along x direction is v cos theta into minus I cap, this is final speed, minus v cos theta into I cap. So you can take minus sign common, it will be v cos theta plus v cos theta, so that is 2v into cos of theta. And you want change in momentum, so it will be mass times the change in speed. Okay, so it will be mass times the change in speed, so it is m times 2v into cos of theta. All right, and what is cos of this theta? Theta is 60 degrees, so cos of 60 is half. Okay, so therefore m into delta vx is equal to m into 2v into half, so 2 and 2 gets cancelled. Okay, so it is equal to mv. So option A is the answer. Okay, it is simple, right? Yes or no? It's simple, and this kind of problems were repeated, okay, in NEET exam. All right, let's move on to the next problem. A body of mass m hits normally to a rigid wall with velocity v and bounces back with the same velocity. Okay, see, it's the similar problem, and this is easier one. It's from NEET 2011. The impulse experienced by the body is, what is impulse? It is change in momentum. So there is this body, let's suppose this ball, it hits this wall. Okay, it hits this wall with some speed v and it bounces back with the same speed. But if you think about the velocity, initial velocity will be minus, or it will be v times minus I cap. Okay, final velocity will be v times plus I cap, because initial one is in negative direction, negative x-axis, final one is in positive x-axis. Okay, so what will be change in velocity? Change in velocity delta v bar is equal to what? Final velocity minus the initial velocity, which is v times minus I cap. So it is 2 times, okay, because this minus minus becomes plus, so it is 2 times v into I cap. And if you want momentum, okay, the change in momentum, so it will be m times this. Okay, so in magnitude it is 2 times m into v. Exactly similar and even simpler compared to the earlier case, but this was asked in 2011 and the earlier problem was asked in 2016. Okay, all right, let's move on to another problem. A 0.5 kg ball moving with a speed of 12 meters per second strikes a hard wall at angle of 30 degree with the wall. It is reflected with the same speed at same angle. Again, simple problem from NEET 2006. Okay, so I have taken some problems from some years, so you can I mean, imagine how many times this type of problems are repeated. Okay, so if the ball is in contact with the wall for 0.25 seconds, the average force acting on the wall is, okay. So we have what, a 0.5 kg ball. So mass of ball is 0.5 kgs. Then it hits the wall with the speed of 12 meters per second. So its initial speed is 12 meters per second and reflects at an angle of okay, it hits at an angle of 30 degree with the wall. So let's suppose, okay, let's draw it like this, it will help. So this is my wall, okay, and this is a ball that I'm throwing at the speed of 12 meters per second. So it hits the wall at some angle and it is reflected. So for reflection, we know angle of incidence is equal to angle of reflection, okay, in ray optics. So this angle is 30 degrees, it's given. So this angle must be 30 degrees, okay. So now what happens is it has got two velocities, two components of velocities. So this will be, if this angle is 30, this will be 30, okay, alternate angles. So this is v into cos of theta, this will be v sine theta. Again it gets reflected, okay. So again we can resolve its velocity in two components. Magnitude remains same. So this angle is theta, so this angle will also be theta, its corresponding angle. Yeah, good morning Shakti. So this will be v cos theta and this is v sine theta. Again, as you can see, there is no change in the vertical component of velocity, which is v cos theta, but there is change in the horizontal component. And how much is the change? So as we have done it twice now, so change will be 2 times of v sine theta, okay. So final, if you consider this v sine theta, then initial will be minus of v sine theta. So v sine theta minus v sine theta, it will be 2v sine theta, okay. So we can find out force now. Force is equal to what? It is mass into delta v by delta t, change in velocity with respect to time. And now we can substitute values. So mass is 0.5 and how much is change? It is 2 times v into sine theta. V sine theta becomes what? Minus v sine theta. So change is 2 times v sine theta. So 2v sine theta, and theta is how much? It's 30 degrees. Theta equals to 30 degrees, okay, divided by time. Time is 0.25 seconds. So 0.25. And we can substitute for v also, it is 12, okay. Yeah, so let us solve this. So 2 times 0.5, 2 times 0.5 is how much? It is 1, okay, and v is 12. So 12 divided by, we have 0.25, all right. So 0.25 times 4 is 1, so 1 over 0.5, or in denominator if you have 0.5, you can replace that with 4 in the numerator, okay. And you have sine of 30. So how much is sine of 30? Is it's half, all right. Or you can do 0.25 into 2, it's 0.5. So 12 upon 0.5 will be how much? It will be 24. So answer is 24 newtons, okay. Simple again, right? Okay, then again let's move on to the next problem. Next problem, body of mass 3 kg hits the wall at an angle of 60 degree and returns at the same angle, the impact time was 0.2 seconds. This is exactly similar problem. Okay, so the force exerted on the wall will be how much? Okay, exactly similar. I am not going to solve this. Okay, so you can solve. I will share the notes on Telegram group and you can solve this problem. Okay, because we have solved it 3 times already. Okay, an explosion, I'm sorry, and an explosion breaks a rock into 3 parts in a horizontal plane. Two of them go up at right angles to each other. The first part of mass 1 kg, I'm sorry, extremely sorry. Okay, so yeah, better. An explosion breaks a rock into 3 parts in horizontal plane. Two of them go off at right angles to each other. The first part of mass 1 kg moves with a speed of 12 meters per second and second part of mass 2 kg moves with 8 meters per second. Okay, speed. If third part flies off with 4 meters per second, then the mass is. So there is an explosion. It breaks the rock into 3 parts in horizontal plane. Two of them go off at right angles to each other. So let's suppose we have a rock and it breaks into 3 pieces. Okay, so it breaks into these 3 pieces. Two of them go like this, one goes like this, or no, not like this, at right angles to each other, right? Not opposite to each other. So one goes like this, another goes like this. Okay, one in this direction, another one in this direction. So this is one piece of this block, rock of mass m1. This is another of mass m2. So third one should go something like this. Okay, its angle can be different, but something like this. It depends on the components. Okay, m3, it goes like this, let's suppose. So then two of them goes at right angles to each other. The first part of mass 1 kg moves with the speed of 12 meters per second. So m1 is given, it's 1 kg and its speed is 12 meters per second. Okay, so v1 is 12 meters per second. Okay, second part of 2 kg moves with 8 meters per second. So its mass is 2 kg and it moves with 8 meters per second. So this is v2. Okay, and then if third part flies off with 4 meters per second, third one is moving with 4 meters per second, then its mass is, okay, so this one is moving with 4 meters per second. So its speed is 4 meters per second. We don't know about the angle. All right. So we can substitute these values into what? We need to consider here the law of conservation of momentum. So this is an explosion. There is no external force. So what we can say is, so m1 into v1, okay, plus m2 v2 bar plus m3 v3 bar must be equal to 0. Okay, then what is direction of v1? It's along y-axis. What's direction of v2? It's along x-axis. Okay, so I can write that. So m1 has mass 1 kg. Okay, its velocity is 12 meters per second along y-axis. So I will write 12 j cap plus second one has mass. How much? Its mass is uh, its mass is 2 kg. Okay, and its velocity is 8 meters per second. So it's along x-axis, right? So 2 multiplied by a into I cap. And third one, it flies off with 4 meters per second. Okay, So we don't know about its mass. So we can take m3 v3 on other side. So this should be equal to minus m3 into v3 bar, right? So now we have magnitude of v3. Okay, so we have 12 j cap plus 8 times 2 is how much? 16 I cap. So 16 I cap plus 12 j cap should be equal to what? Minus of m3 into v3. So now how much is magnitude of v3? It is 4 meters per second. How much? What should be the direction? So it should be same as that of resultant of these two. Actually opposite, because we have the negative sign, right? So we have to find out m3, and we are given with the, okay, so I can say it should be v3 can be written as, it can be written as its magnitude v3 multiplied by unit vector in the same direction. Okay, so how much is the magnitude? It is 4. Okay, multiplied by, we can write unit vector in same direction, and if we take 4 on the other side, what will we get? It will be 16 I cap plus 12 j cap divided by 4. Okay, that will be 4 I cap plus 3 j cap equals to minus m3 multiplied by unit vector in same direction. So now we have this left hand side and right hand side. So here we have unit vector and here we have some vector. Okay, so this thing should be equal to what? Its magnitude multiplied by unit vector in this direction, right? Okay, so it should be, how do we find magnitude? Okay, it will have some magnitude. Let's call it, suppose, a bar. Okay, so it will have some magnitude and unit vector, right? It is m3 v3 cap. So we just want magnitude of a bar, because what will be direction? So direction of this a bar and v3 bar, they are opposite to each other, right? So magnitude will be ax square plus ay square. So it is a equals to square root of ax square, which is 4 square, plus ay square, which is 3 square. So 4 square is 16, 3 square is what? 9. So 16 plus 9 is 25. So a equals to what? 5. So how much should be the mass? Okay, m3 should be equal to magnitude of a bar, and that's equal to what? 5 kgs. So option D is the answer. So yes, is it clear? Is the problem clear? Okay, then let's move on to the next problem. All right, so next problem is an explosion blows a rock into 3 parts. Is it the same one? No, this is from NEET 2013. This is from 2009. So 2 parts go up at right angles to each other. These two are 1 kg first part moving with velocity 12 meters per second, 2 kg second part moving with 8 meters per second. The third part flies off with velocity 4 meters per second. Its mass would be, okay, this is a repeated problem with values too. Okay, the values of all the quantities are also identical. Okay, so how much was the mass? 5 kg. So option D is the answer. All right, so it is exactly same. It's the same last problem. So repeated in 2009 and 2016, NEET 2016. Okay, let's see another problem. So you can see in first part there are so many repetitions. Okay, so there are many problems were asked on law of conservation of momentum. Okay, you can see this is the one of the most important topic of this chapter, the law of conservation of momentum. Okay, so a 1 kg stationary bomb is exploded in 3 parts having mass 1, 1, 1 is to 1 is to 3 respectively. Parts having same mass move in perpendicular direction with velocity 30 meters per second. Then velocity of bigger part will be. Again, it's similar, right? So there are 3 parts of a stationary bomb. Stationary bomb breaks into 3 pieces. Okay, so we have a bomb which breaks into 3 parts. One flies off like this, another one flies off like this. So this is M1, its mass is suppose M, M2, its mass is M. Okay, the ratio is 1 is to 1 is to 3. So M3 goes in this direction, its mass is, it should be 3M. Okay, so according to the law of conservation of momentum, total momentum before explosion was 0. So total momentum after explosion should be also equal to 0. So we have m1 v1 bar plus m2 v2 bar plus m3 v3 bar equals to 0. Or we wanted to find out what? Parts having same velocity move in perpendicular direction. So these are the two. Then velocity of bigger part. So we want to find out velocity of this bigger part. Okay, v3 we have to find out. So let's take these two on the other side. So we get m3 v3 bar equals to minus of m1 v1 bar plus m2 v2 bar. Now let's substitute the values. So what are the values? So v1 and v2 is given that it's 30 meters per second. Okay, so let's substitute values. So m3 is 3 times m. So we have 3 times m into v3 minus v1 is what, 30 j cap because it's going along y-axis, and v2 is 30 I cap, it's going along x-axis. Okay, so it is m times v1 is 30 j cap plus m2 is m times 30 I cap, it's moving along x-axis, right? So what do we get? So m gets cancelled out, as you can see, m and m gets cancelled out. We can take it common and cancel it out, and then we can take 3 on the other side, so it goes into the denominator of this thing. So v3 bar will be equal to minus of, if we divide 30 by 3 it will be 10, so 10 I cap plus 10 j cap, and we wanted its magnitude only. Okay, so this, it should be 10 root 2. How? So magnitude is v3 equals to square root of vx square, which is minus 10 square, plus vy square, it is also minus 10, so minus 10 square, so it is 2 times 10 square, which is 100. So square root of 100 is 10, so it's 2 times, sorry, root 2 times 10, 10 times root 2 meters per second. This should be the answer. So option A is the answer. All right. So again, this was similar problem based upon the law of conservation of momentum. Okay. Next, a mass of 1 kg is thrown up with velocity of 100 meters per second. After 5 seconds, it explodes into 2 parts. Okay. So explosion means law of conservation of momentum. into two parts. One part of mass 400 gram comes down with velocity of 25 meters per second. The velocity of other part is, okay, so there is one mass which is thrown up. Its mass is 1 kg. Okay, so this is thrown up. It is thrown up with some velocity with 100 meters per second. So u equals to 100 meters per second. Okay, and after 5 seconds, so let's find out what will be its velocity after 5 seconds. But after 5 seconds, what happens? It goes somewhere here. Okay, and it breaks into two parts. So one part moves up. Okay, one part moves up and another part moves down. Okay, so part of mass 400 grams comes down with some velocity, with velocity 25 meters per second. All right, so let's solve this. So initial velocity u is 100 meters per second. Let's find out what will be its velocity at this point. Okay, so we can use this formula. V is equal to u plus dt, sorry, at, and a is what? A is acceleration due to gravity, but the ball is moving up, acceleration due to gravity is down, so that means it should be negative. Okay, so u is 100, a is minus 10, it's given to be 10 meters per second square, but it will be in opposite direction as that of motion, so negative, multiplied by time is 5 seconds. Okay, so that's minus 50, 100 minus 50 is 50 meters per second. So now our problem is reduced to a ball of mass 1 kg which is moving in this direction with 50 meters per second, and there it breaks into two parts. One part goes up, another part goes down. Okay, so according to the law of conservation of momentum, we can say what? Suppose its mass is m, so m times its initial speed here is v, m times v bar is equal to m1 v1 bar, which is velocity v1 is the velocity of this mass m1 which is going up, plus m2 v2 bar. Okay, so then let's substitute the values. What are the values? So m is 1 kg, m2 which is going down is 400 grams, so it's 0.4 kg, and m1 which is moving upward should be what then? Because it's 1 kg ball or 1 kg mass which is breaking into two parts. Mass of first one is 0.4 kg, so mass of second one should be 1 kg minus 0.4 kg, so it is 0.6 kg. So it is 1 kg, this is 0.6 kgs, this is 0.4 kgs. Okay, and then velocity is v1 bar plus v2 bar, its velocity is v bar. So let's take this on the other side. So what do we get? We get 1 kg multiplied by its velocity was 50 meters per second, it's upwards, minus we have 0.4 kgs, okay, multiplied by its velocity is, because it's coming down, it's minus 25. Okay, 25 meters per second but coming down, so minus 25, and that's equal to what? 0.6 multiplied by velocity of the first part. Okay, so that is 50 meters per second, and this minus minus will become plus. Okay, so 0.4 multiplied by 25, so it is 10, so plus 10 meters per second, so it is 0.6 times v1, so this is 60 meters per second. Okay, 50 plus what? 10, and we can take that 0.6 on this side, so we get v1 equals to 60 upon 0.6, so 10 meters per second. Okay, so did I miss some point or something? I guess I missed a point. Oh no, it should be, it was already 60. It's not 60 upon 6. It is 60 divided by zero point 0.6. So it is 100. Okay, my mistake. Yeah, so it is 100 meters per second is the answer. Okay, so again, this was a simple problem based upon the law of conservation of momentum. Then let's move on to the next problem. Next problem is a particle moving with velocity v bar is acted by three forces. So three forces are shown here. Okay, and shown by this triangle PQR, the velocity of the particle will be. So now if you look at this triangle, this is first force, this is second force, this is third force. You can call anyone first, anyone second. Okay, so if you start at this point, if you take this first force, then addition of this plus this will be what? It will be a force like this. Okay, but then you are adding this third force into it, which is of same magnitude but exactly opposite direction. So what will be the resultant force? Resultant force will be 0. Okay, and therefore now let's see the options. The change according to the smallest force QR, the velocity of the particle will, okay, it will remain constant since the net force is 0. Okay, so net force is like you are applying force in this direction, then you are applying force in this direction and this direction, which cancels out. Okay, and therefore the velocity will not change, it will remain constant. This was very simple, and okay, it was in NEET 2019, from NEET 2019. All right, let's see another problem. Three forces acting on a body are shown in the figure. To have the resultant force only along y direction, we want resultant force only along y direction. Okay, the magnitude of the minimum additional force needed is, okay, so we need some additional force, let's say. Then what should be the magnitude of that uh, additional force is the question. All right, so we can resolve these three forces along x and y components, and let's suppose we need some force, let's call it F. Okay, so these three forces, they are acting on a body, they are shown like this. To have resultant force only along, we want force along y-axis only. The magnitude of minimum force, minimum additional force is, okay, so let's see what happens. So we'll resolve it. Before that, this force can have any direction. Okay, so let's add these forces. So this force we can resolve in two components. Okay, so it is 4 newtons. So it is 4 cos of 30 will be along vertical direction, and 4 sin 30 will be in horizontal direction, right? Then, okay, so it will be like this. So this is 4 cos 30 in vertical direction, 4 sin 30 in this direction. Let's resolve this. 1 Newton force, it is at 60 degree with the x-axis. So this component will be 1 into cos of 60, and there will be one vertical component will be 1 into sine of 60. And then we have this 2 Newton force. So it can be resolved in two components. Okay, and since this angle is 30, this angle must be 30 because these are vertically opposite angles, right? So this component should be 2 times cos of 30, and the component along this direction should be what? 2 times sine 30. And what do we want? We want resultant force in y direction only. Okay, that means we need to apply a force in x direction to balance out whatever leftover force is there in the x direction. Okay, so let's do that. So let's calculate what is resultant of these forces in x direction. So it is 4 sine 30. Okay, this theta is 30, right? It's 4 sine 30. Okay, theta equals to 30 minus, because these are in opposite direction, right? So minus 1 cos 60 minus 2 sine 30. So how much is sine 30? Sine 30 is half. Okay, and cos 60, cos 60 is also half. Okay, so that's good. Saves us calculations. So it is 4 times half minus 1 times half. Okay, minus 2 times half. So 4 times half minus what? 1 times half. Okay, minus 2 times half. So it is 4 by 2 is 2, and 1 into half is half, that is 0.5, minus 2 times half is 1, so it is 2 minus 1.5, so it should be 0.5, right? So there is 0.5 Newton force acting in x direction, and we need to exert the force in opposite direction. So because resultant force is towards left, the force to be applied must be towards right. How much is that? 0.5 newtons. Okay, so this is the answer. All right, so it was simple. Yeah, let's move on to the next problem. Okay, so previous problem was just calculations. Let's move on to the next problem. Which one of the following statements is incorrect? Which one of the following statements is incorrect? So let's read the statements carefully. Rolling friction is smaller than sliding friction. Okay, then limiting value of, okay, this statement is correct, right? Rolling motion has least amount of friction. Okay, so first one is correct. Limiting value of static friction is directly proportional to normal reaction. This is also correct. We have seen this, that static friction is directly proportional to normal reaction. Then frictional force opposes relative motion, so this is also correct. Then last one must be incorrect, so let's read that too. Coefficient of sliding friction has dimensions of length. So it is coefficient of friction, it is dimensionless. Okay, no dimensions. That means this is the correct option, but this statement is incorrect. Okay, correct, incorrect statement and the correct option. All right, let's move on to the next problem. A plank with a box on it at one end is gradually raised about the other end. So we have this box, okay, and there is a plank which is raised, gradually raised like this. At the angle of inclination with horizontal reaches 30 degrees, the box starts to slip. It starts to slip, okay, when theta equals to what? 30 degrees. So theta is angle of friction, right? Theta must be angle of friction, because we have seen that when we raise the height of a plank or a plane, the angle at which bodies begin to slip down, okay, bodies begin to slide, that angle is known as angle of friction, and coefficient of static friction mu s is given by what? It is given by tan of that angle, okay, which in this case is 30 degrees. Okay, so then it slides 4 meters down in 4 seconds. So this is given. The coefficient of static and kinetic friction between the box and the plank will be respectively. So let's find out the coefficient of static friction first and see this question. is just mu s is equal to tan of 30, and that's what we want. Okay, so mu s is equal to tan of 30, and that is equal to what? Sine 30 divided by cos 30, and that's equal to what? Sine 30 is half, cos 30 is square root of 3 by 2, and this 2 we can take into numerator, or we can cancel it out with this 2. So we'll get it is 1 upon root 3. Okay, or this can be written as it is root 3. I will multiply and divide by root 3. So this becomes 3. Okay, what I have done is I have multiplied and divided by root 3. So we'll get root 3 is 1.732 divided by 3, and this is close to, okay, this is close to what? I mean 1.8 divided by 3 will give me 0.6. So this is nearly equal to 0.6, I can say 0.5 something. Okay, so the static friction will be 0.6, and we know that kinetic friction is smaller than the static friction, so we need not solve it. Okay, because in options we are given that it is 0.6 and one option lesser than that. Okay, it is 0.5. So option D should be the answer. We can solve it and check, of course, but we need not solve it because we don't have that much time. So kinetic friction is less than static friction. So let's do this. Okay, this is the answer. Why? Because kinetic friction is less than static friction, and we got static friction equals to close to 0.6. So lesser than that is 0.5. Okay, C can't be the answer because both cannot be same. Okay, so yeah, so I was solving it, but we need not solve it, right? Okay, so we need to do some smart tricks in between. All right, so a system consists of three masses m1, m2 and m3 connected by a string passing over a pulley P. Okay, the mass m1 hangs freely, so this is mass m1 which hangs freely, and mass m2 and m3 are on rough horizontal table. The coefficient of friction equals to mu, the pulley is frictionless and of negligible mass. The downward acceleration of mass m1 is, okay, so there are three masses m1, m2 and m3, okay, connected by a string passing over a pulley P, and mass m1 hangs freely, m2 and m3 they will come along, okay, they are on rough surface, its coefficient of static friction is mu. The pulley is frictionless, the downward acceleration, we have to find out downward acceleration, and it's given here that m1 equals to m2 equals to m3, and that's equal to m. All right, so let us try to solve this. So what will be net force? Net force is downward, suppose. Okay, so net downward force is m times g, because masses m1, m2 and m3 are equal, so net downward force is mg. And what is the opposing force? So there will be force, the frictional force acting on these two blocks in this direction, and how much is that? So mass of this one is m, mass of this one is m, so combined mass is 2 times m, so 2 times m is the combined mass, and combined weight will be 2 times mg. So their normal reactions is equal to what? Let's say normal reaction here is n1, here it is n2, so n1 plus n2 is equal to 2 times mg, right? So after that, what is the net force? So the net force will be the downwards force, which is mg, minus the frictional force, okay, that is mg, minus what is frictional force? It is mu s, or mu here, because its coefficient of static friction is mu, times the normal reaction, which is 2 times m into g. Okay, so this is the net force, and it can be written as mass times acceleration. So we can take m common from here. Okay, m into g minus 2 times mu into g. You'll be left with this. We can take mg common actually. Okay, let's take m common. So m gets cancelled. So acceleration equals to what? G minus 2 times mu g, and from there too we can take g common. Okay, so it has to be, okay, net force. Net force is what? It is total mass times acceleration, right? So what is the total mass? The mass of this block, and there are these two blocks also. Okay, so net mass is 3, not, okay, 3 times m, not m. So this 3 will go on the other side. So we get acceleration equals to g, we can take common, 1 minus 2 mu divided by 3. So this option C should be the answer. Okay. Yeah.